Hello and welcome to EE 233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at some functions in our core.c and core.h library. Specifically, we're going to take a look at the suite of functions that allow for us to export data from a two-dimensional array into a file for persistent storage. So notice I have several functions here. In this video, we're going to specifically focus on the export int 2D array, export double 2D array, and the export char 2D array. And we'll leave the export string 2D array to another video. First thing to note is if you're using an older version of this file, you'll notice that there is a minor change that I have made. Specifically, in that I have switched the file name and the delimiter to a constant character vector. In both cases, we're going to assume that we are being provided strings, in which case this will allow for us to have a multi-character delimiter. While those are not often used, it is a nice luxury to be able to have. So I have left the change in the description of this video. So if you do have an older version of this source file, as well as the header file, please make sure to make those changes. So without further ado, let's go ahead and get started. We'll need a couple of temporary variables to begin with. If you'll notice that I am creating an array, or excuse me, I'm accepting an array that is up to n max rows and m max columns, that if we assume that the first dimension are rows and the second dimension columns, but I'm also providing n and m, which indicate the actual number of rows and columns that are used in the array. So technically, this is a little bit inefficient way to do this, in that you're essentially allocating more space than you actually use, and you can refine this for your own application. For right now, though, we're going to specify both the n and the m. In other words, we are going to specify the maximum number of rows and the maximum number of columns. I want to take a second to point out that our n should be less than our n max, and our m should be less than our m max. And this is something that you would want to do in your error checking. All right, so let's get started here. We're going to need an integer that's going to serve as the index for the rows. You could call this row index. I'm just going to keep consistent and call it n index, and then I'm going to also have a m index. And then I would also like to throw in a results variable, and we'll have a little bit of a discussion about what those results are going to look like in just a second. But let's go ahead and initialize our results equal to 0 and make sure to return our results. Now, the other thing, since we're doing file IO, we will also need to have a file pointer, and we're going to call this one output. And that should probably get us everything that we need. So the very first thing that we want to do is we want to go ahead and check to make sure that our n and m are less than our n max and our m max respectively. Otherwise, it could lead to some unappreciated behavior. So the first thing we want to do is check if our n max, or our n, is greater than or equal to, or rather greater than our n max. And if it is, we simply want to print a message to the user. This is error. N is larger than n max. You could also consider providing to the user what the n max was. So we'll say do it like this. So n equal to %d is larger than n max equal to %d. Basically, you want to have some sort of useful information back to the user. If we do decide to use the %d's, we of course then need to provide the information here. So n and then n max. And just a reminder, the n max is actually a constant that is defined in our core.h. We can then follow this up with an else if, and our else if would check to see that our m is greater than our m max, and likewise we would simply say printf error m equal to %d is larger than m max equal to %d. And then, of course, in those placeholders, we simply put m and m max. Now, we're assuming that we have covered all of our bases here, we would go ahead and jump into an else. In other words, the only time that you would get this else if you ended up with a satisfactory number of rows and columns. The other thing that you would probably also logically want to check is that our n is greater than 0 as well as our m greater than 0. Now, fortunately, that does not have a negative impact necessarily on our functionality here. It just means, as you'll see in just a minute, the way we write it is that it effectively does nothing other than generate an empty file. So you could argue that we would probably want to check that as well. We're going to skip that and let you do that on your own. But now what we want to do is we want to jump into opening the file. And so to begin with, we're going to say output is equal to fopen. We're going to specify the file name that we have passed in our function signature, and we are going to open it for writing. The very first thing that you want to do when you open any file, whether it be for reading or for writing, is to check to make sure that the output file pointer is not equal to null. And if it is, you want to provide an error to the user that says something along the lines of error failed to open. And I would suggest going ahead and providing a message to the user that indicates what the file was that you attempted to open. Now, this leads us to another interesting little piece of discussion, and that is we could also check using our own string length function whether the user has in fact provided a valid file name. And one of the basic checks that we could do is whether or not the string length of the file name is greater than 0. So logically then, another thing that we could check here using our else if is else if string length of our file name. And this is where you want to think a little bit about what constitutes a valid file. If we insist on it having a file extension and a name, then it must be at least 3 characters long, including the period. So in other words, you could have something like a.a as a file. Well, technically not all that useful. It is a valid file. You can also have a file without an extension. So barring that discussion, at the very least, you would want to have a file name that was at least 1 character. And so what we want to do is we want to check to see if our file name is less than or equal to 0. And if that's the case, then we simply say printf error invalid file name. And like I said, once again, you would consider doing some additional error checking there. So this just assumes then that a 1 character file name is adequate. Now, in the true branch of our if statement here, we now can start writing our contents of our file. And so basically, once we've checked that we've opened the file successfully, what we want to do now is we want to set up a nested for loop that allows for us to loop through our array. And we're going to start by looping through the rows first. So our outer for loop is going to look something like this. For n index equals to 0, n index less than n, which is the number of rows that we have, and then n index plus plus. And then the inner for loop looks very similar with the m variables now. So we have m index equals to 0, m index less than m, and m index plus plus. And now inside of this nested for loop is where we are going to use a fprintf. And the first parameter of our fprintf is going to be the output file pointer. And we want to be aware of the type of data we have. So in this case, it's going to be an integer. So we're going to use the %d placeholder followed by a %s. The %s is going to be for our delimiter. So the first placeholder gets the data that is in the array at the given n index, m index. Remember that since it's a two-dimensional array, we're going to have two indices. And then for the %s, you simply provide the delimiter. Now, this almost works. And by almost, I mean this will print one extra delimiter. And more importantly, it will never go to the next line. So what we ultimately want to do is we want to print up to m-1. And by doing that, then that will allow for us to print the data in the columns up to the last piece of data or the last column. And we append the delimiter onto all but the last piece of data. On the last piece of data in the row, we want to append the new line. And so we have one more additional fprintf statement using our output file pointer. And in this case now, we want to print %d followed by the new line. And we only provide it with array square brackets n index m index. Now, I would encourage you to go back and take a look at how our nested for loops work to understand why you don't have any additional changes to be made in the code, particularly why this m index will result in printing out our last column. But aside from that, the only thing that we have left to do is once we have opened our output file, and we are sure that in fact we have, meaning that we've checked it, that the output is not equal to null, and outside of our nested for loop, we want to follow this up with an f close. You always want to remember to close your file. Now, this brings us to our last question, our last detail with this particular function. What do we want the results to look like? And so I want to take just a second to talk about the options for the results. So the results could be success or failure. The results could also be the number of characters printed, or the results could also be the number of data or the number of pieces of data that was printed. Printed, of course, to the file. So I've got a couple of different options here. I personally like the first and the third. The first is probably the easiest to implement, in that wherever you have a failure, you simply return or set results equal to exit failure. And if you recall, we can also say results equal to exit success. And so basically everywhere that you trapped a condition that you didn't want to handle, in other words, that you didn't want to handle the scenario where the M was greater than the M max, in other words, that the indexing was going to go out of bounds of your array, before you even tried to write the file, you just simply present an error to the user and set the results to exit failure, and then the user would know something went wrong when they do the error checking on the return. So in this case, same here. And as long as you did not have an error, in other words, that you hit one of these conditions right here, in other words, if you fell into this else and you successfully managed to write the file as well as close it, then you would simply return exit success. We can come back in a later video and take a look at how you would go about printing the number of pieces of data, but essentially all that would mean is that inside of your nested for loop, you would add a results plus, as well as in this, after this fprintf statement. Once again, it's a nice way of being able to track how much information was stored in the file. Really depends on the purpose that you have for your function. Now, before we start testing these, let's talk a little bit about the similarities between these other functions. You'll notice that we have a export double 2D array as well as a export char 2D array. Function signatures are very similar, the only difference being the data type of the array that we are sending. Now, if you'll notice here, the data type for the first one was an integer, and that dictated what the placeholder was in the fprintf. Likewise, in the second printf, there was a %d. So really the only thing that you need to change is going to be the data type associated with, the format spec associated with the data type. So in this case, for a double, then you would want to use the format spec associated with the double, and for a char, you would use the format spec associated with it. All right, so let's see this in action. So we're going to go ahead and create another little switch or if statement in our main. So I'm going to go ahead and borrow the name of our function and go back to our core driver. The only thing we want to do in this particular case is we want to provide it the sample array, and for this example, we are going to, in fact, actually just hard code the file name because we don't want to make this one too complicated. So in this case, then we will just simply have to pass then the name of the executable, which is going to be our argv0, and argv1, which is going to be the switch or the functionality that we want to test. So we're going to keep this suite pretty straightforward. So we'll have an else if, and if our argc is equal to 2, and string compare I, argv square brackets 1. If that matches then the switch export int 2D array, we'll just do all the setup inside of this branch. And what I mean by that is we'll actually go ahead and instead of declaring the array at the top of the file, we're actually just going to go ahead and do this in here just for demonstration purposes to keep it close to the code that's going to use it. So the first thing that I want to do is I want to create a two-dimensional array, and we're going to name this array underscore int. And like in the function signature, we're going to specify that is going to be n max and mmax. So we're making this, quite frankly, pretty huge, okay? Because if you look at the values for those constants over here in the core.h, you'll see that we're making 100 by 100 array. Now, we're not going to use anywhere near that amount, but we do want to go ahead and create a n index and an m index to put something interesting in this array. Now, I want to go ahead and build this array, so I'm going to use the nested for loop here. So for n index equals to 0, n index less than, I'll tell you what, we're going to actually just make it a 8 by 10 or 10 by 8 rather. So this will be for the number of rows is going to be 10, and then for m index equals to 0, m index less than 8, m index plus plus. And then we're just going to build the array essentially to look like a multiplication table. So our n indexed element and our m indexed element is just going to be a multiplication of the two. So n index plus 1 times m index plus 1. Essentially our multiplication table from earlier. Now, notice in particular that we have not used the entire array. As a matter of fact, we've left 90 rows and 92 columns empty. So we're really hardly utilizing this array. And so hopefully you understand or see the inefficiency of hard coding these max values in there. But what we want to do now is we want to say results equal to export int 2D array, and we want to pass to it array underscore int. We want to specify that we only have 10 rows and we have 8 columns. Essentially, the rest of the data in the array is garbage, and we want to provide to it a file name. And so in this case, I'm going to just keep consistent with the name of the function signature here. So I'm going to call this one int 2D array, probably not the most creative. And I'm going to call it .csv. And the reason I'm going to call it .csv is because for the delimiter, I am going to use a comma. Now notice I have double quotes around this, which indicates that it's going to be a string as opposed to a single character. And also note one other thing, that I could have made the array integer in my function a constant as well. So when you're, sorry, it's over here in the other file real quick. So you notice over here, we could have made this a constant as well. Now, at this point, then, I want to simply print f the results of calling our function. So it's going to be results and then %d followed by a new line, and then whatever that value for the results happens to be. All right, so let's update our help briefly. So we'll have a printf, and we'll provide this string, this switch with no additional switches. By the way, we can always come back and have another version of this that would accept maybe the parameters for n and m, as well as the file name and the delimiter. But I wanted to keep this first example very, very simple. So I'm going to go ahead and build this, and barring any errors, we can come out here to our command window. And the first thing, if I do a dir, you'll notice that I only have the files that we had been using earlier, our sample users.csv, which is I have open in NetBeans, and also the sample wiki that we used in an earlier video. And so I'm going to go ahead and run my core demo.exe. I'm going to provide that switch export int 2D array and hit enter. And we see our results are 0, which corresponds to exit success. So unless I've got a logic error, I should now have another file called int2darray.csv. If you're on a Windows machine, you can simply type explorer.exe with a space and then a period, which will open the current directory. And I'm going to drag my int2darray.csv over to NetBeans. And sure enough, you'll see that I have the results of a rather boring multiplication table, but a multiplication table nonetheless, where I have 10 rows and 8 columns. Notice that the first 7 pieces of data have a comma appended on the end, whereas the 8th piece of data has a new line appended on it. So that gets us our integers. What would you suspect you change for your doubles? Well, the reality of it is very, very little. As a matter of fact, the only thing that changes is that format spec. So if you want to, you can very carefully go ahead and copy all of your code from your int version and paste it into your double. And then very carefully go in, and you're going to be interested in changing the fprintf for the one that's inside the nested for loop. And we're going to start by just simply putting in %f, and we're going to see if we like that or if we want to refine that just a little bit. Obviously, if you're doing this for a specific application, you may tweak your format spec. You can also provide it actually as an argument to your function, so you have a little bit of flexibility there. And then we want to figure out a way now for us to be able to test this. And so to do this, then we want to go back up here to our main over in our core driver.c. And once again, we've got to make some changes. Namely, instead of an array of integers, what we want to do is we want to have an array now of doubles. So what I'm actually going to do is I'm going to borrow this code, meaning I'm going to actually make a complete copy of it here. And I'm just going to make some changes here. So we're going to start off, we're going to change our int to a double and our array int to a array of doubles. And we know from earlier that if we store a double in an integer, we lose precision. However, in this particular case, we're going to store an int as a double. So essentially, it's just going to get casted as a double. So we don't really have to change any of our calculations. We're just going to wind up with essentially too much stored capacity for an integer. So effectively, there's going to be very little to change. And then down here, the only other thing that we want to do is we want to change the call to the function. So in other words, instead of export int 2D array, we want to call export double 2D array, and we want to go ahead and change our file name to double 2D array.csv. So let's go ahead and build this one. And let's see, did we miss one of our changes? Let's see here, what did we do? Ah, yes, we had one more change when we were actually constructing our array here. So we want to go ahead and make sure that the array that we declared is also the one that we initialize. And One more place. So we got a few other places. I was being a little too optimistic there. Let's see now if we've caught all of them. One last time here. There we go. All right, so let's go ahead and call it now with the export double. See, I have one more change there in my switch. It's being entirely too optimistic there. Basically, everywhere you have an int, you want to go ahead and change to a double. All right, one last time, go ahead and build it. And let's come out here to our command line. We're going to run our core demo.exe, this time with the export double 2D array. We'll get our results of 0, which indicates success. We'll go over to our folder, and we now see a double 2D array that has a size greater than 0 and also the timestamp of today. So we should now have a two-dimensional array now stored as a CSV file. Same values, different precision. In this case, we're using double precision, whereas we were using integers earlier. And you can change that behavior by modifying your format spec. So a common one that I suggest is %8.2, something along those lines, because that then allows for you to have a total of 8 with 2 decimal places after, two decimal places rather. So where you have a %f, you would just change this to %8.2f. Now, hopefully you see the pattern in this. I'm going to leave the char 2D array for you to build. And when we come back, I'm going to show you how to test it. So at this point in the video, what I would encourage you to do is pause, see if you can complete the char 2D array, and then resume the video and look at my solution, see if it matches yours. All right, so welcome back. Hopefully your export char 2D array looks similar to mine. The main difference, of course, is that you have a %C here instead of the earlier example of %D for integers and %F for doubles. Now, let's get to the business of actually testing this. And if you go back to your core driver.c, we want to go ahead and set up one more example here. We can go ahead and use our template, but we're going to make a little bit of changes to it. So we'll start off, we'll go ahead and put our else if inside here. And this time around, we will remember to change these early on. So we're going to change this to export char 2D array. And we want to go ahead and set up some of our temporary variables. The first one, of course, is going to be the array itself. So char array char, and we once again are going to make it nmax and mmax, but you could put other values in there. And we will also need the indexes. So our n index and our m index. Now, as I was thinking about what would we want to put into our character array, some practical examples of this might be the results of a true-false quiz for a group of students or a multiple choice quiz for a group of students. But I thought it might be a little bit of fun for us to look at a mathematical relationship here using the modulo operator, or as some of y'all may know it as the remainder operator. So we're still going to go ahead and build our nested for loop. So we're going to start off with for n index equal to 0, n index less than, and this time around we're going to make it an 8 by 8. Essentially think of a chess or checkers board. And then in index plus plus. For the inner loop, we're going to do the same. So for m index equal to 0, m index less than 8, and then m index plus plus. A little bit of cleanup here, add your curly braces, and now let's get to the business of actually filling our array. And what we're going to do here, we're still going to insert it the same way that we did in our previous examples. So we're going to specify the n index and the m index, but what we're going to put in the array is going to be dictated by an if statement. So we're going to leave this here for just a second. We're going to use this just 1 second. But what we want to do instead is we want to control what characters go into this array based on the indexes. And what I'd like to do is I'd like to create the pattern on a chessboard or a checkers board. And if you look carefully at that pattern, depending on the orientation or the type of board that you're working with, you'll basically notice that one color falls on the even increment or even indexed locations, while the other color falls on the odd. So depending on which way you're looking at the board, 1, 1, 3, 2, 2, 3, 3, 4, 4, and so on are all going to have the same color. So how can we mimic that? Well, you'll also notice that if the position 1, 1 is one color, then the position 1, 3 is also the same color, as well as 3, 1. The position 1, 2 and 1, 4, as well as 2, 1 and 2, 4 are going to have the same color. And so what we're going to do is we're going to leverage that. And how we leverage that is by looking at the relationship between n index. So if n index mod 2, if that value is equal to the value of m index mod 2, let's make sure our parentheses match up. If this is the case, what we want to do now is we want to take our two-dimensional array, and it doesn't really matter what value you put in there, but basically we want to put a color in there, for instance. So maybe we'll do a red and black. So we'll set that equal to R. And then under the else, then we would simply set it to a different value. And I'm going to make this one be for black, and then close the curly braces. And so basically, if the results of the modulo operator or the remainder operator, when applied to the row index, is the same as the results when applied to the column index, then we should end up with an R. And if there's any difference between the two, we should wind up with a B. All right, so let's give this a shot. So outside of our for loop, then what we want to do is we want to say results is equal to export. In this case, we're going to use our char 2D array, specify array underscore char. We're going to hard code the 8 and the 8 in there. The file name, we're going to keep consistent with the previous examples. That is just going to be char 2D array.csv. And for the delimiter, then we're going to specify a comma. And then lastly, we'll have a printf with our results and the %d, which will be either success or failure, followed by a new line, and then whatever the value is for the result. So let's go ahead and build this. Let's see if this is successful. Come out here to our command window. and we'll replace our export double 2D array with export char 2D array, and then hit enter. We have results. There's 0. That looks promising. Let's do a dir now from the command line. You'll notice that we have a char 2D array up here, and it seems to at least have data in it. It's smaller. It's roughly around the size of our int. Let's see what we've got in here. We'll go over to MinGW folder, and we'll drag and drop this now into NetBeans. And if you notice here, we have R, B, R, B alternating, starting with BR, BR, and the next row, first and third row match, the second and the fourth row match, etc. You can also play around with this a little bit. We'll come back here to our core driver. We'll make one little change here. We can technically make this delimiter anything we want. So I'm actually going to take out the comma. Let me go ahead and build this real quick. It'll still work. And I'm going to come over here to the command line. I'm going to rerun it by just hitting the up arrow twice and hit enter. Still successful. And now you notice that I've removed my comma. So technically we don't even have to have a delimiter. So you can play around with this some more, and you can try multi-character delimiters. Maybe for whatever reason you might want to do something like this. And we'll uncomment this one. All right, and once again, you'll see now I have multiple characters as my delimiter. So have some fun with this. Hopefully you found this this video useful. As always, if you've got any questions or comments, don't hesitate to ask. Remember to take a look at my next video where I talk a little bit more about my string 2D array. And thank you for watching.